Hello, we're still working in Chapter 9, Section 2, Characteristics of Quadratic Functions. So what have we done so far? Seems like a lot, but I don't want you to think that like any of it's really truly that difficult. We found zeros by looking at the graph where it crosses the x-axis. We found the axis of symmetry by looking at the graph. Last video, we found the axis of symmetry by looking at the function, the equation or the expression actually for the function. It's still hard. It's the equal sign kind of messes things up, but it's really not an equal sign. I know that's a little confusing, right? But one of the things, and I'm finding my graph paper with that, or the paper that we used. In this video, we are going to find the vertex if I have y equals ax squared plus bx plus c, right? And this is the main idea. I'm going to go back. You've seen this before. This is the main idea. When we did finding the axis of symmetry, I know the book Dr. Berger does the whole add these two together, divide by 2, which works. It's fine. But I said what's really important is that you understand the axis of symmetry goes through the vertex. The axis of symmetry goes through the vertex. So each of these, the axis of symmetry, I drew it in green, went through the vertex. Here, 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 and here. Also, if you remember when I talked about it, on this vertical line, this one right here, every x value is the same. All the x's right here going up and down, all the x values are -3. The y's are different. The y's change. So here's -3, 1, -3, 2, -3, 3, -3, 4, and even all the fractions in between them, -3, -1, etc. But since the since the axis symmetry goes through the vertex, they share the x value. So if I wanted to find the vertex, I already know what the x coordinate is. All I have to do is figure out what the y coordinate is. And that we can do. So here's the steps. I'll leave this up here. To find the x coordinate of the vertex, first you find the axis of symmetry. We did that in the previous video. It's b over -2a, right? So we're going to start with y equals ax squared plus bx plus c. If it is not in standard form, first of all, you have every right to complain, okay? But if it's not in standard form, you have to put it in standard form. So you got to move all the x's and then any extra numbers over on one side, and the left side has to be just y, or f of x, all right? Then I find the axis of symmetry. The axis of symmetry is a vertical line. Vertical lines have equations. So it has to be the b over -2 times a. That's that b, whatever's being multiplied by the x, divided by -2 times whatever that number is. Then the vertex, and this is a bad way of writing it, but it'll make sense, okay? The vertex is going to be this number, and again, it might be a fraction like we saw, or it might be a nice number. Not that fractions aren't nice, but just something that we don't need to talk about fractions. How do I find the y value? To find the corresponding y coordinate, substitute this into the function. So like say whatever number this is, say it's 5. Then I do something times 5 squared plus something times 5 plus something, whatever the a, b, and c are. And the way we write that is we write f of b over -2a. But of course this looks complicated, but it's not. Then step 3 is write as an ordered pair. That's what we have, okay? So this is the first time really that we're going to have to do any, how do I say, like some calculations. And it's not going to be too difficult. It'll be fine. You can do it. There's two things I got to do first. Find the axis of symmetry. That gives me the x coordinate of the vertex. So the first thing, all of these, if you look, they're already in standard form. My a equals -1, my b equals -2, and my c, which I can't see anything, is the hidden 0. So my axis of symmetry is going to be x equals b, which is negative 2, divided by negative 2 times a, which is negative 1. Multiply negative 2 times negative 1 in the bottom, and then divide, or reduce if you need to. Negative 2 times negative 1 is positive 2. So this becomes negative 2 over positive 2, which then becomes negative 1. So x equals negative 1 is my axis of symmetry. Okay, and actually, this part right here, I just showed you that because that's what I'm doing in my head. All right? You can do all this in your head. Now, that's my axis of symmetry, but that's also the x-coordinate of the vertex because the axis of symmetry goes through the vertex. So I take that negative 1 and I substitute. So I do y equals the opposite, that negative right there, of negative 1 squared. Subtract 2 times negative 1. That's negative x squared, subtract 2x, which is what I have here. Exponents come first. Negative 1 times negative 1 is positive 1. So I got the opposite of positive 1, subtract 2 times negative 1. I'm going to multiply. The opposite of positive 1 is negative 1, and negative 2 times negative 1 is positive 2. And then I add. Negative 1 plus 2 equals positive 1. I even put the plus sign in front of it for you. So my vertex, the x coordinate is negative 1. Sorry, I got the hiccups. And the y coordinate is positive 1. Okay, as always, pause, rewind it, watch it again, ask questions. It's kind of hard since this is one-sided in a video. So if you need to go back and look at that, just pause the video real quick. I'm going to keep working with the second one. So for 5x squared, subtract 10x plus 3, my a, my a is 5, my b is negative 10, and my c is 3. Of course, I don't care about the c for this problem. So my axis of symmetry is going to be x equals b, negative 10, over negative 2 times a, which is 5. Now, in my head, negative 2 times 5 is negative 10. So in my head, I've got negative 10 divided by negative 10. That tells me my axis of symmetry is x equals positive 1. That's also the x-coordinate of my vertex. So now I'm going to find the y-coordinate. I write y equals 5 times 1 squared. So I replace that x with 1. Subtract 10 times 1 plus 3. Take care of exponents first. 1 to the second power, 1 times 1 equals 1. So this is 5 times 1, subtract 10 times 1 plus 3. Next step, I'm going to multiply. 5 times 1 is 5. 10 times 1 is 10. And I haven't done anything with 3 yet. Now I'm going to add and subtract at the same time. This is a great moment for me to step off and pause for a second and show something that people do that is wrong. Notice I've been following the order of operations. We call the order of operations PERMDAS to remember what it is. And yes, there's an R in there. It's not PEMDAS. All right? Even if we follow this, I did exponents first because exponents are right here. Then I multiplied because multiplied is right here. And then we get into a little problem because now I want to add before I subtract. So I'm going to add 10 plus 3, get 13, and I'm going to do 5 subtract 13. And then I'm going to get my test back and I'm going to find out I was wrong. But why am I wrong? That's because these two, and these two actually all happen at the same time. Okay? So I actually like to say this instead. It's actually PIMA. There's no such thing as subtraction. It's a big lie we've been perpetrating on people. Subtraction just means adding the opposite of what you're subtracting. So you can think of this as 5 plus negative 10 plus positive 3. And it makes it a lot more simple. There's also no such thing as division. That's multiplying by the reciprocal. And this is why people sneak and leave out the R. because there's really no such thing as roots or radicals. It's just exponents to rational, well, sorry, values with rational exponents. So that's how we get around that. Okay, but a mistake I see students make is they know a is written before the s, so they add 10 plus 3. Just remember, subtraction means adding the opposite. So I'm going to do 5 plus negative 10 plus 3. Whenever I add 3 things together, I have to pick 2 of them first to start with. So if I do 5 plus 3 first, I get 8, and 8 plus negative 10, or 8 subtract 10, is going to be negative 2. Now, you might think, well, I heard that I'm supposed to go left to right. Yeah, you can do that too. So what's 5 plus negative 10? That's negative 5, and then negative 5 plus 3 still equals negative 2. Or negative 10 plus 3 is negative 7, and 5 plus negative 7 is still negative 2. I'm using what's called the associative property. When I add 3 or more numbers together, it doesn't matter which 2 that I pick. The associative property means just pick any 2. And this is kind of useful when we do mental math back in elementary school, but I don't know if your elementary school teachers explained it that way. So after all that discussion, because it's important, my x is positive 1, my y is going to be negative 2, and my vertex is going to be 1, negative 2. Finally, I'll do this one without all the side comments about it. Try to scoot that up, get some space in there. My a is 1, b is negative 4, and my c is negative 10. And you know what? This is where, man, bad habits. I should not even write equals, okay? Because when I write a equals 1, it makes me think like I'm doing an equation or something. I'm just saying that a is, in this case, a placeholder is the number 1. All right? So actually I should say is instead of equals. Those things are really related, but I don't want to get into the details in this video. So what's my axis symmetry? X equals b, which is negative 4, divided by negative 2 times a, which is 1. Negative 2 times 1 is negative 2. A negative divided by negative is a positive. 4 divided by 2 equals 2. So I get x equals 2. And that'll be the x value of my vertex. Now I got to find the y value. So I write 2 to the second power, because I got x squared. Subtract 4 times 2, subtract 4 times x, subtract 10. Take care of the exponent first. This is 4, subtract 4 times 2, subtract 10. Now I multiply. 4, subtract 8, subtract 10. And I'm near the bottom of my page here. I'll try to move it up so you can see it. You can also write this as 4 plus negative 8 plus negative 10. Going back to that idea of subtraction is adding the opposite. So I don't care which 2 you start with. Sometimes people like putting all the positives together and all the negatives together. For some reason that kind of like just reinforces what's going on. It doesn't matter. So 4 plus negative 8 is negative 4. And negative 4 plus negative 10 is negative 14. So I'll write over here, y equals negative 14. That tells me my vertex is 2, negative 14. All right, we will be doing more examples of that in the practice problems videos that are coming up.